Okay, we are going to continue the first order differential equations, okay, under the fourth type, which is a fourth type the fourth type, which is the exact differential equations. Okay, can you hear me or not?
Yes, Doctor.
Okay,
Yes, Doctor.
yeah, thank you.
Yes, doctor.
So, okay, for the introductions of the exact differential equations, okay, let's say if given the z equal to fxy, z is a function of x and y, and let's say is equal to x squared minus 5xy plus y cubed equal to a. Given z is a function of, you have x and y, and let's say equal to a here. Okay, and then if we do, okay, if we oh, if we do, okay, mm, the total differential del f del x dx plus del f del y dy on z here. Okay, this operation is actually the total differential. Okay, the first one, del f del x, is a partial derivative respect to x, and then okay, dx is a small changes of the x here, plus partial derivative of, okay, f is actually equal to the z here. Okay, this is respect to y, and then dy is a small changes, okay, on y. Okay, and let me see what is this pen here. Okay, z is actually equal to f. If you do the del f del x, for example, let's say, and you differentiate respect to x where the y is constant. Okay, it's actually what you do is you del x. When you del x, y is constant plus y cube. So mean, okay, for differentiations, okay, if addition and subtraction, you can break it term by term. So you have del x, x squared, okay, and then minus, okay, del x, you have the 5xy, okay, plus you del x y cube. So when you do del x, x squared, okay, like your ddx, here we can have del x and del y because we have function of two variable x and y. When you do del x, y is actually constant. Okay, but here is only so del x, here you don't have the y, so it's only like you do the ddx x squared, so you x squared, you have 2x. Okay, when you delta x here, you have x and y. So when delta x is actually y is constant. So phi and y is constant. Like you have a, like your differentiate maybe, let's say, k time of x, where the k is a scalar you can factor out. So you have to factor out phi y, and then you delta x x. Okay, and then when you delta x y, okay, y cube, where the y is constant, so delta x a constant, you will have 0. Then we got this one is 2x. So delta x, x you have 1. That's why you get here. This is actually the result for del f del x is 2x minus 5y. So when you do del f del x, okay, multiply with dx, we have, okay, it's actually 2x minus 5y. And then you have dx. Okay, and then similarly, okay, when you change, okay, when you do del f del y, so del f del y, when you differentiate respect to y, x is constant. So it's actually you del y x squared minus 5xy plus y cube. Okay. You similarly you can have the del y x squared. So minus del y 5xy plus you del y y cube. So when del y, okay, function of x, which is constant, so when you differentiate, okay, constant respect to y, the result is 0. Okay, so when you del y, okay, phi is constant, so phi times x is constant, constant you can factor out, so you have, okay, negative 5x, and then you del y y. Then del y y cube, you got 3y squared. Okay, and then here delta y power 1, you have 1. That's why I have this is negative 5x plus 3y squared. So I can put, let's say you have 23y squared minus 5x, okay, dy. Okay, and then if you, okay, here, del f del x plus del f del y, then, okay, if it differentiates, okay, constant we have, okay, 0. So from the z equal fxy equal to a, if we do the total differential del f del x, okay, dx plus del f del y dy, and then let's say we let it equal to 0 here, we'll get, okay, this, okay, differential equation where we can denote, okay, let's say m dx plus n dy equal to 0. Okay, we have this, okay, this form, m dx plus n dy equal to 0. And then, okay, our okay, problem here mean if given m dx plus n dy equal to 0, mean given this one, our problem is actually if given the differential equation m dx plus n dy equal to 0. Okay, how are we going to obtain its solution? How to solve this, okay, m dx plus n dy equal to 0? Okay, then if you have this, okay, this form m dx plus n dy equal to 0, okay, first step you can check, okay, whether your m dx, you check is it del m del y equal to del n del x. Okay, you cross it. Coefficient of dx here differentiate respect to y, coefficient of dy differentiate respect to x. If del m del y equal to del n del x, okay, then, okay, the differential equation is what we call exact differential equation. So mean, okay, if given the differential equation m dx plus n dy equal to 0, and when you find del m del y equal to del n del x, then this differential equation is called exact differential equation. Okay, and if this is exact differential equation, how are you going to obtain its solution? Okay, then from here, okay, for let's say from this equation here, let's check whether this one is exact differential equations or not. Okay, can I erase it? Okay, let me. Before I erase here, do you have any problem? Okay, in doing the partial derivative or not? Del f del x del f del y.
Doctor, can you explain one more time the del x bracket x square how it becomes the third line there 2x? Mean from the second line,
Yeah,
how
yeah.
do you change it to third line?
Okay, this one you del x x squared. Like you differentiate. Okay, ddx x squared. Okay, for differentiation
Oh,
power you become multiplication. So 2, and then, okay, differentiation power, okay, you have here 2 become, bring in front 2, and then x squared for differentiation 2 you minus 1, so x power 1. If integrations, if you integrate x squared dx will be x, okay, power 2 increase by 1, so 2 plus 1 3, so divide by 3.
okay, okay, I got it already.
Mm. And then this one is like ddx. Okay, this one del y x squared, because when you del y x is constant, that's why 0. So del x y cubed, because when you del x y is constant, so differentiate del x constant, you have 0. Okay, it's here del x phi xy, when you del x phi times y is constant, so factor out. And then del x is like ddx x power 1. Okay, you will have ddx x power 1, you have what? 1. ddx, okay, x power 1 is 1. And then this one same thing. Okay, and then I'm going to erase it. let's check, okay, whether from the z equal to a, when we do del f, this is what we call total differential. We obtain this one. Then, okay, let's denote, okay, this specific example here as m dx plus n dy equal to 0. Okay, I'm going to check, okay, whether this differential equation is exact differential equations or not. Okay, where is it? Yeah, where is the cursor? Okay. So now, okay, well, let's get the m is a coefficient of dx. So m is 2x minus 5y. So coefficient of x dx here differentiate respect to y. So you have del m del y. Okay, the same thing. Okay, same thing. Del y 2x minus 5y. You can do it as del y 2x. Okay, minus your del y 5y. So del y x will be 0. So del y 5y, you will get 5. So the answer is negative 5. And then, okay, when you do, the n is the coefficient of dy. So n is actually 3y squared minus 5x. Okay, for coefficient of dy, it differentiate respect to x. So it's opposite. So that's why you del x 3y squared minus 5x, okay, is equal to, you can break it term by term. So del x 3y squared minus your del x 5x. Okay, for del x, okay, y is constant. That's why okay, the first term you obtain 0. Del x 5, okay, minus del x 5x, you have, okay, negative 5. So you notice, okay, del m del y equal to del n del x. Mean given, okay, a differential equation in the form of m dx plus n dy equal to 0, you can check whether del m del y equal to del n del x. If it is true, then the differential equation is called exact differential equation. So in this case, del m del y is negative 5, del n del x also negative 5. Hence, hence 2x minus 5y dx plus 3y squared minus 5x dy is actually exact differential equation. This is actually, okay, what we call short form exact differential equations. Okay, if exact differential equation, later on, how are you going to obtain its solution? Okay, actually the solution is here, because the solution, okay, for this exact differential equation is actually x squared minus 5xy plus y cubed equal to a. Mm, we go to another page or new page. No need to erase. Why not up? Okay, so here, okay, as I explained just now, if we have a m dx plus n dy equal to n dy equal to 0, the differential equation is exact if and only if del m del y equal to del n del x. Okay, example, okay, this equation 1 is actually from our introductions, okay, example where we have the z equal to fxy, okay, equal to a. I mean, this example 1 is actually from, okay, the previous example here, this one. From this z equal to fxy, when I do del f del x dx plus del f del y dy, I get this, okay, the first, okay, differential equations. Okay, how can I go to this? Okay, this one. So, okay, we have shown just now this k differential equation is exact because k del m del y equal to del n del x. We label the coefficient of dx is m, coefficient of dy is n, because both are equal to -5. And then k, if the differential equation is exact k equation, hence k, how are you going to obtain the solution back? So the exact k differential equation has a function fxy equal to a. Mean the solution is actually the z equal to fxy equal to a constant a. Okay, which satisfy del f del x equal to mxy and del f del y equal to nx, okay, nxy. Okay, because in the introduction just now you see that you have the z actually equal to f x y equal to a. Okay, when we do the total differential equation, del f del x dx plus del f del y dy, okay, differentiate a, you have 0. Okay, this is what we denote as m dx plus n dy equal to 0. Okay, from here, from z, when you do total differential equation, okay, del f del x we denote as m, del f del y we denote as n. Okay, then the solution is actually the fxy equal to a. I mean, the solution for the exact k differential equation is actually fxy equal to a. Okay, then to obtain back the f is actually you can get from del f del x equal to mxy. Then to obtain the f, okay, this is del del x. To obtain f, then we, okay, mean you integrate respect to x both hand side. Integration, okay, integrate and then delta x dx cancel out, we obtain fxy. That's why the fxy is actually you integrate m dx. Mean from scale the exact differential equation, you can obtain the f by directly put up the integral symbol to the first term. So mean you, the f is actually, mean the shortcut is actually fxy is equal to you integrate m dx. Okay, when you integrate, okay, here, this is partial integration. When you integrate respect to x, okay, the constant can be a function of y or only normal constant. Okay, and then, as we know also, del f del y equal to n xy. Then, okay, we can obtain the function of f. Okay, to get f, you can integrate this dy. So this one, you integrate both hand side. That's why fxy can be equal to the, okay, mean from the this differential equation, fxy can be obtained by taking by integrate the second term here respect to y, and the constant is the function of x or just a normal constant. Okay, and then you obtain 2 fxy, right? So you can combine that solution, okay, or from the first equation, okay, or from the first equation you can, okay, obtains the function of y in the second, okay, equation, or you start from the second equation, you can obtain the function of x from the first equation, or you take a new term, then you obtain the solution of the exact equation is actually fxy equal to a. Okay, before we proceed, okay, to the example that we, okay, obtain from the introduction part, do you have any questions or not? Okay. Mean, given this differential equation, if you are, okay, show that this is exact differential equation, then to obtain the solution, what you need to do, fxy is actually equal to, okay, take the first term, you integrate respect to x. Okay, fxy, okay, this is what I call equation 1. Okay, you can obtain fxy also by taking the second term here, you integrate respect to y. So you got two equations. So from equation 1, you may locate the gy into second equation. If you start from equation 2, you locate the function of x into first equation. Then finally the solution is actually f xy equal to a. Okay, why you said the solution f xy equal to a? Because you already since that it's actually m dx plus n dy equal to 0 is obtained from here. From z equal to fxy equal to a, when we do the total differential equation, we obtain this one. So mean, okay, like you do, okay, as you learned in the calculus, when you ddx fx, you obtain your okay f prime x. Okay, and then okay, this is differentiation. For integration, it's actually you reverse. When you integrate f prime x dx, you get back fx. Okay, this is one is here, this one is here. ddx fx, you get f prime x. So given f prime x, you integrate back respect to x, you get back fx. So that's why here, when you see your integration, okay, this is f prime x is actually df dx dx. So you see like this one, why you integrate del f del x dx, you get back f. So given z equal to fxy equal to a, we obtain m dx plus n dy equal to 0. That's why if given m dx plus n dy equal to 0 and it is exact differential equation, then the solution is actually fxy equal to a. And then how to obtain fxy? Okay, to obtain fxy, you can integrate the first term. Okay, here, the first term here, respect to x. Or you integrate the second term respect to y. So you got two equations. When you got two equations, okay, you can take out all the term from equation 1 and then add up with a new term in equation 2. Then that will be your fxy and you let it equal to a. So this is a solution of the exact differential equation. Okay, any questions? Any questions? Okay, if no, we'll proceed to the example. Okay, so notice this one is actually okay come from the introduction parts where after I do the okay z equal to, and from the introduction part you have the z equal to the fxy equal to a there, and then just now we all shows that this m, this n, so you have the form m dx plus n dy equal to 0. Okay, m is actually coefficient for dx. So for m coefficient for dx, you differentiate respect to y. So del y. Del y 2x minus 5y, we obtain negative 5. Coefficient for y, okay, you differentiate respect to x. Then we obtain negative 5 also. Since del m del y equal to del n del x, okay, as what we shown in the beginning parts, hence this exact differential equation, this differential equation is actually exact differential equation. Okay, so now we are going to look at how to solve this exact differential equation. Okay, we have this one as what we label as m dx plus n dy equal to 0. Okay, to obtain the solution, okay, as you know that m is actually del f del x. Okay, and then to obtain the f, then it's actually you integrate m dx. In here, first term, you integrate respect to x, then you integrate 2x minus 5y respect to x. Okay, please take notes, this is actually partial integration. when you integrate respect to x, y is constant. Okay. Then you integrate 2x respect to x. For integrations, okay, x power 1, so you're, okay, 1 plus 1, you have 2, and then divide by 2. Okay, when you integrate respect to x, phi y is constant. So integrate a constant respect to x, you have the constant, which is phi y multiplied by x. Okay, partial integration, that's why your, okay, your scala is actually the constant, the scala constant is actually your f, let's say put gy. So this is what we denote as the first equation. Okay, and okay, this term is actually del f del y is actually equal to n. Hence, to obtain the f, exactly you integrate n dy. Where the n here, this one, integrate negative 5x plus 3y squared dy. So when you integrate respect to y, x is constant. So you integrate negative 5x, which is constant. So integrate a constant respect to y. You have a constant, which is negative 5x multiplied with y. Okay, integrate 3y squared. You got 3 power 2. 2 plus 1 is 3. So you divide by 3. Okay, normally plus c, but this is a partial integration where the x is constant. That's why we put the constant is a function of x. Okay, this one you can put negative 5xy plus y cubed plus hx. Okay, this is the equation 2. Okay, f is actually fxy. Yeah? Okay, that's why from equation 1, you obtain x squared, okay, minus 5xy. Okay, gy is function of y only, which is actually y cubed. So plus y cubed. And we know the solution of the exact differential equation is fxy equal to a. Then the solution is this one. I mean, if you start from equation 1, okay, you can also, okay, let's say you start from equation 2. Okay, if you start from equation 2, okay, your solution will be your fxy. Okay, you start from equation 2, you have negative 5xy plus y cubed. Hx is a function of x, which is referred to here, which is x squared, and then equal to a. So you see, either you start from equation 1 or you start from equation 2, you should obtain the same solution. Or another way is actually, okay, you start from equation 1, this is x squared minus 5xy. Okay, if you get confused how to obtain your gy, okay, what you need to do, you start from equation 1, you have x squared minus 5xy, and then, okay, you go to equation, add up with the term from equation 2, provided you take the new term. Okay, negative 5xy have been taken, so you no need to take. Okay, this is a new term, that's why you add up with y cubed. And then you, okay, then you, okay, you can ignore gy or hx here. I mean, the third way is actually you combine combine equation 1 and 2 by taking new term only. New term only. But don't add up. If you add up negative 5xy, total is negative 10xy. So we obtain actually fxy is x squared minus 5xy plus y cubed. You can check back into the introduction part. Okay, just now what I given is actually fxy is equal to x squared minus 5xy plus y cubed. You can check back. Okay, I'll to quickly check it. By the way, see all slide. Let's see. Initially, from introduction part, we give you z equal to fxy is actually x squared minus 5xy plus y cubed. after we do the total differential equation, we obtains actually that differential equation 2x minus 5y dx plus negative 5x plus 3y squared dy. If we check it, it is actually in the form of m dx. Mean initially we give you this one, and after we do del f del x dx plus del f del y dy equal to 0, we obtain m dx plus and dy equal to 0. Okay, this k differential equation is exact. Okay, if mean the del m del y equal to del n del x. If del m del y equal to del n del x, then this is actually exact differential equation. If this is exact differential equation, okay, how are you going to obtain its solution? Actually, the solution is given by fxy equal to a. So how to obtain the f? Because okay, m is actually from the term del f del x dx. N is actually from the term del f del y dy. Okay, that's why to obtain means it actually your del f del x equal to m. Hence, to obtain the f, you can integrate m dx. Mean from the first term you integrate respect to x, and you know del f del y equal n. Hence, f also can be obtained by integrate n dy. Mean quickly is actually first term of a exact differential equation, you integrate respect to x. Second term, you integrate respect to y. Combine them, the solution will be fxy equal to a. Okay, so do you have any question before we proceed to the second example? Where is it just now? Okay, do you have any questions? Not this one. Okay, if no, we move to I think the second example. Okay, if you got no question, okay, we move to the second example. Solve exponent 2y minus y cos xy dx plus 2x exponent 2y minus x cos xy plus 2y dy equal to 0. So we notice it is in the form of it's in the form of m dx plus n dy equal to 0. So mean if you see you have the differential equation in the form of m dx plus n dy equal to 0. Hence, first step you can try to check whether del m del y equal to del n del x. Okay, when you check this one. Okay, if yes, then this is exact differential equation. Then the solution is actually fxy equal to a. So first step, check whether this is exact differential equation or not. Okay, so m is actually coefficient of dx. So you have your m is exponent 2y minus y cos xy. Then you find del m del y. Then you del y exponent 2y minus y cos xy. Okay, then you del y exponent 2y. So minus, you del y, y cos xy. Okay, first term, del y exponent 2y, differentiations. So you differentiate 2y is 2. For differentiations, is 2 times exponent 2y. If integration will be exponent 2y divided by 2. Okay, and second term, you notice we want to differentiate respect to y, you have y multiply cos xy. So for this one, you have to apply the product rule, where you have the u is actually y, the v is actually cos xy. So you want to del y. So this will be del u del y. You have 1. And this will be del v del y. Okay, when you del y, x is constant. Okay, so you have differentiate cos is negative. So you have negative x sin xy. Okay, del v del y. Okay, anyone having problem or not? Like, okay, if you have, let's say if ddx cos phi x, the answer is negative phi sin phi x. So same thing, where the x is a constant, like phi here. Okay. So del y, the result will be u del v del y. So it will be negative xy sin xy. Okay, plus v del u del y. I mean plus cos xy. So this is del m del y. Okay, and then n is coefficient of dy, n in this case. Okay, n. Okay, n is 2x exponent 2y minus x cos xy plus 2y. So for coefficient of y, we'll differentiate respect to x. So this is del n del x. So we del x each term. So del x 2x exponent 2y, okay, minus x cos xy plus 2y. So you del x each term. So del x 2x exponent 2y. And then minus you del x x cos xy. Okay, plus del x 2y. So for the first term, when you del x, y is constant. So mean 2 exponent 2y is constant. That's why you factor out 2 exponent 2y. Then you left del x 2x. Okay, second term, when you del x, okay, this is x. Cos xy have function of x, okay, like here. So second term, you need to use a product rule. Okay, where no space, I erase this part. Okay, so for delta x, where the u is actually x, yeah, v is cos xy, this is del u del x del x. Okay, for delta x, x cos y, u let it equal to x. Then you want to do delta x, so it's del x u. The answer is 1. So this is del v del x. Okay, you differentiate respect to x. Now y is constant. Okay, so this one become y. So you have negative y sin xy because delta xy is constant. So factor out y. And then, okay, when you delta x cos is negative. That's why negative y sin xy. Okay, the result is u del v del x, which is negative xy sin xy plus v del u del x. So plus cos xy. So now you check it del m del y. Okay, here haven't. This one haven't done. So 2 delta x 2x, you have 2, so total is 4. Okay. Exponent 2y minus xy sin xy plus cos xy. Let me check whether the equation got some mistake. Example 2. Suppose this is exact differential equation. Second term same, third term same. Okay, the first one. Okay, let me check whether I got typo there. Two x exponent 2y minus x cos y del m del y del n del x. Uh, oh, sorry. Already factor out 2x, so this one no more x. Here, okay, for del n del x, delta x 2x exponent 2y. I already factor out 2 exponent 2y. Okay, mean I already factor out 2. Delta x 2 is constant, exponent 2y is constant, so this one no more. So delta x is 1, that's why this one, the answer is 2 exponent 2y. Because 2 exponent 2y already factor out. So this one just left delta x, which is 1. So the result is 2 exponent 2y. So you see del m del y equal to del n del x. Okay, mean this is this, okay, this meaning is sin del m del y equal to del n del x. Okay, therefore, okay, this is, it is actually exact differential equation. So, okay, given m dx plus n dy equal to 0, if del m del y here is equal to del n del x, then this differential equation is exact differential equation. So example 2, this is exact differential equation. Okay, if exact differential equation, later on, okay, how are we going to obtain its solution? And we'll go to the next slide. Yeah. So we have shown, okay, this one is exact differential equations. Okay, now, okay, how are we going to obtain the solution for the exact differential equation? Okay, as we know, okay, coefficient for dx is m, coefficient for dy we label as n. Okay, and then we know that coefficient for dx is actually del f del x equal to m. Hence, your fxy is actually equal to, you integrate m dx. Then you integrate exponent 2y minus y cos xy respect to x. I mean, just take like the first term, integrate respect to x. When you integrate respect to x, okay, y is constant. Y is constant. Okay, so that's why you integrate. Okay, this one you integrate term by term. When you integrate exponent 2y, y is constant. So you have the constant multiply x. That's why this is x exponent 2y. Okay, and then you integrate second term. Okay, all right, do it slowly. This one is, okay, mean this one you integrate exponent 2y respect to x, and then integrate y cos xy respect to x. Integrate constant respect to x. We have the constant, which is exponent 2y multiplied by x. Okay. Integrate y cos xy respect to x, where the y is constant. So y here constant, you can factor out. So y, and then integrate cos xy dx. You have x exponent 2y minus y here. Okay, for integration, integrate cos is positive sin. So you have the sin xy. Where you integrate respect to x, y is constant, so divide by y. Okay, like you integrate cos 7x dx, the result is sin 7x divided by 7. So where the y here is constant, so that's why I get sin xy divided by y. So this is plus integrate respect to x, the constant, okay, is a function of y. So this one you can simplify. You get x exponent 2y minus sin xy plus gy. Okay, this is the first equation. The first equation. Okay, and then as we know, okay, del f del y equal to n. Hence, we can obtain fxy also by, okay, integrate n dy. Integrate this y, so integrate both hand side respect to y. Okay, where the n is actually coefficient of dy, which is integrate 2x exponent 2y minus x cos xy plus 2y dy. Then you can break it term by term. You integrate the first term respect to y. You integrate 2x exponent 2y dy. Okay, then minus integrate x cos xy dy plus you integrate 2y dy. Okay, when you integrate respect to y, x is constant. So 2x here is constant. Okay, let me change the color. Integrate respect to, okay, y, 2 times x here is constant. Okay, this is constant. So constant, you can factor out the constant 2x and then integrate exponent 2y dy. So they can become, you factor out the constant. So integrate cos xy dy. Okay, integrate 2y, you have the y squared. Okay, you actually 2y squared divided by 2. Okay, this is partial integration. So when integrate respect to y, x is also a constant. That's why hx. Okay, and then you have 2x. Integrate exponent 2y, you have exponent 2y divided by 2. Integrate cos xy is positive sin xy, where the constant is actually x, so you divide by x, like here. You integrate cos 7x sin 7x divided by 7, where the constant is actually x, so you divide by x. Okay, this one is plus y squared plus hx. Okay, you can simplify. It become x exponent 2y minus, okay, x and x cancel, is actually minus sin xy plus y squared plus hx. Okay, and the solution for the exact differential equation, okay, is actually fxy equal to a. Okay, so how to obtain your fxy? Okay, easy. We start from equation 1. Take out all the term from equation 1. You have x exponent 2y minus sin sin xy. Gy is actually function of y here. So plus y squared equal to a. Done. If you start from equation 2, then you have x exponent 2y minus sin xy plus y squared. Hx is function of x. Exactly. Mean if you start from equation 2, 1, 2, 3, same three term. Hx, when you look at, okay, to get hx, you look at equation 1, okay, only the term with x only. You cannot see this is x and y, this is x and y, this is a gy. That's why hx here is actually 0. So that's why the solution is fxy is actually equal to x exponent 2y minus sin xy plus y squared equal to a. Okay, do we have any questions here? Any questions? Go, or am I too fast?
Doctor,
Yes,
doctor, how come the minus one and minus two in the last equation?
minus m
Minus one
minus 1.
and minus two.
Which is it? This page
Yeah, the last line in the last line.
or last line?
Uh-huh.
Okay, last. I mean the solution fxy,
Uh, the blue color,
blue
the blue
color.
color. Ah,
Oh,
left hand side.
this is not minus 1. This I label equation 1.
Oh, okay, okay, okay.
I mean the fxy is actually x exponent 2y minus sin xy plus gy. This is not minus 1.
Oh, okay, okay, okay.
Equation 1.
Okay, okay.
I
Thank
mean
you, doctor.
this line is equation 1. This is not minus 2. This one equation 2. Mean you can obtain fxy by integrate, okay, the m dx here. Mean you can actually quickly once you prove this is exact differential equation, to get the fxy you can integrate first term respect to x. Fxy can be obtained also by integrate, okay, the second term respect to y. So you got two fxy here. So you can start from the first k equation. Okay, because when you integrate respect to x, the constant is the function of y. So you locate the function of y into second equation. So you obtain y squared. Or if you start from equation 2, so you see you still have the same three term. Hx, you look at equation 1, must only x. You don't have, that's why it's 0. So it's either you start from equation 1 or 2, you must obtain the same fxy. Or the third way is actually, okay, you take out equation 1, just ignore gy or hx. So one term, two term. Okay, go to equation 2. Okay, this is a not new term, so don't take it. Not the new term, don't take it. This is a new term, so you add up with y squared. And then we know the solution of the exact differential equation must be fxy equal to a. So this one must be equal to a. If we just put fxy and then we'll deduct you, okay, the marks there. The solution of exact equation is fxy equal to a. So here, okay, for exact differential equation, you may a bit confused because to prove whether this is exact, you have to prove del m, they cross, del m del y, and then del n del x. If del m del y equal del n del x, then this is exact differential equation. Okay, you don't prove the other round. Don't prove del m del x equal to del n del y. Make sure this one. Or you can put like this one, del x, del y. M put here, n you put here. And then like you do determinant of a matrix. Okay, will be del n del x minus del m del y. Okay, or del m del y. Okay, I mean like you do determinant, and this one the determinant must be 0. That's why del m del y equal to del n del x. Okay, this one you learn in the multivariable calculus. This is what we call curl. They are related actually. Okay, and then we move to, I think, no, and show. Okay, we go to the third. Okay, the third example. So given dy dx equal to xy squared minus cos x sin x over y bracket 1 minus x squared, and y bracket 0 equal to 2. So mean this one, when x equal to 0, y equal to 2. Okay, this means x equal to 0, y equal to 2. So the form, like, so they're given like this one. First, you would start with whether this is separable equation. Can you separate function of y to dy only, function of x to dx? Because normally if you have a plus or minus, then is this one is x, but here you got x and y. So this is not separable. Because it's impossible. Here you got x and y and then minus. You want to break this one to dx or to dy, cannot. Product form can. The quotient form actually can, but because your numerator you have the minus here, so it's impossible to separate y to dy, x to dx. So this is not separable. And then you may check whether this is homogeneous. First one is not separable. Then try to check whether this is homogeneous. If homogeneous, we said power for each term, shortcut, the power for each term must be same. Here 1 is power 2, total is power 3. But this term, when you expand, this is y power 1 only. So the power not the same. So this is not homogeneous. Third, we check whether this is linear differential equation. For linear differential equation, you always can change it to the form of dy dx plus pxy equal to qx. And then is it possible to break it? Let's say you break it. Let's say you have the form dy dx. We want y power 1. If you divide your denominator is one term, you can divide, let's say x y squared divide y 1 minus x squared, so minus cos x sin x divide by y 1 minus x squared. Here, so you have x divide 1 minus x y. And then this is cos x sin x. You have here 1 minus x squared. This is times 1 over y. So you see, for linear differential equation, you have dy dx. This one it will bring here to front, so dy dx. So this is positive, so minus x 1 minus x y. This look like your px. So you have the form dy dx plus pxy power 1. And then the right hand side, negative cos x sin x divide 1 minus x squared. However, you have this extra term here. For linear differential equation, right hand side must be function of x. This look like qx. It's okay. This one you have px times y, but you have the extra term. 1 over y. So the qx is actually qx divided by y. So okay, this one also not linear differential equation, not linear. So it's not separable, it's not homogeneous because this is power 3, this one power 1. Okay, it's not linear because you have here the term qx divided by y. 1 divided dx satisfied, px times y power 1 satisfied, only qx here is qx divided by y. So this is not linear. Hence, let's check whether this is a exact differential equation or not. Okay, for first order, we just learned these 4 types: separable, homogeneous, linear, and exact differential equation. Okay, let's say I erase all these things. Okay, if you got any step, okay, when I explain, you okay can understand, you can okay immediately okay wise up. So to get the exact differential equation, let's we cross multiplication. So you have y 1 minus x squared dy equal to, I have to erase. So you do cross multiplication. So y times 1 minus x squared dy, so equal to, you have the x y squared minus cos x sin x. Okay, the whole thing here multiply with dx. Okay, we want m dx. Mean we want the form m dx plus n dy equal to 0. So the dx term I bring to left hand side, so it become, okay, this one, so negative become positive, so cos this become negative. So cos x sin x minus x y squared dx plus y times 1 minus x squared dy equal to 0. Okay, so now we change to the form m dx plus n dy equal to 0. Okay, then now okay, so let this is m, this is n. Okay, then we find del m del y. Okay, we find del m del y. So mean you del del y, okay, I straight it right, del del y each term, del del y cos x sin x, okay, minus your del del y x y squared. So del del y cos x sin x. When you del del y, x is constant, so the first term you have 0. So del del y x y squared, so you have minus. When you del del y, okay, y squared is constant, so you factor out y squared. Sorry, del del y x is constant, you factor out x. Okay, del del y x is constant, factor out x. Then you del del y y squared. So del del, okay, you have x. Del del y y squared is 2y. So you have negative 2xy. Okay, and then you find del n del x. Okay, del n del x. You del del x. Okay, y 1 minus x squared. Okay, when del del x, y is constant, so factor out y. Then you del del x 1 minus x squared. Okay, del del x 1 is 0. So del del x negative x squared is negative 2x. So the result is negative 2xy. So Okay. This is sin del m del y equal to del n del x. Okay, therefore, this is sin del m del y equal to del n del x. Therefore, okay, this is the exact differential equation. So example 3 here, we have shown it is not separable, it's not homogeneous, it's not a linear equation, but it is exact differential equation. Okay, then if this is exact differential equation, we'll start with this form. I think my okay, or put in this form m dx plus n dy equal to 0. And we have shown, okay, this is exact differential equation. And then as we know that coefficient for dx is actually, that term is del f del x equal to m. Okay, this is m, also equal to del f del x. This is n, also equal to del f del y. Then the f xy, you integrate m dx. Mean integrate the first term with respect to x. Integrate cos x sin x minus xy squared dx. Okay, when you integrate respect to x, y is constant. Okay, this one you may put it cos x sin x is sin 2x divide 2. Okay, dx. So minus integrate x y squared dx. Cos x sin x is equal to sin 2x divided by 2, as you have. When you have the sin 2x is actually 2 sin x cos x. So that's why sin x cos x is actually sin 2x divided by 2. Integrate sin is actually, you have negative cos 2x. Okay, all right. And then divide by 2. All right, divide by 2. Divide by 2 again. And then integrate respect to x, y squared is constant. So you can factor out y squared. And then integrate x dx. So this is negative cos 2x divided by 4. Integrate x, y squared is constant. Integrate x respect to x is x squared over 2. So plus, okay, function of y. Okay, and then the fxy can be obtained by integrate the second term here respect to y, because you have del f del y is actually equal to n. Del f del y equal to n. So mean the fxy can be obtained by integrate n dy. Mean directly second term here integrate respect to y, where the n is actually y1 minus x squared dy. Okay, when integrate respect to y, x, okay, is constant, then you can factor. So 1 minus x squared is totally constant. So you can factor out 1 minus x squared. Then integrate y dy. Because they are in product form, so y times a constant. So you can factor out the constant. So integrate y dy. You have the y squared over 2. So integral constant is a function of x. Okay, this is the first equation. Okay, this is, I denote the second equation. The solution for the exact differential equation, okay, is actually fxy equal to a. So I just put SOL. The solution is fxy. Okay, to get fxy, I start from equation 1. So the solution is negative cos 2x divided by 4. Okay, take out second term is negative x squared y squared divided by 2. Gy, okay, function of y. Okay, from equation 2, if you expand, okay, equation 2, when you expand, exactly you have y squared over 2 minus x squared y squared over 2 plus hx. Okay, this is equation 2. So gy is actually here plus y squared over 2. So equal to a. Solution for the exact differential equation is actually fxy. Start from equation 1, one term, two term. Gy is actually y squared over 2. Okay, this one already taken. Okay, so don't take it anymore. Or if you start from equation 2, you will have y squared over 2, blue one, negative x squared over y squared over 2, which is second term. Hx is actually negative cos 2x over 4. Okay, I change. Start from equation 1, gy is actually y squared over 2. Okay, if you start from equation 2, your hx is here. Then if you start from equation 1, your gy is actually y squared over 2. Okay, if you start from equation 2, hx that you obtain is actually negative cos 2x over 4. Mean the solution is actually your fxy is either you obtain from equation 1 or 2. Mean if you start from equation 1, locate gy in equation 2. If you start from equation 2, locate your hx in equation 1. Or you can combine equation 1 and 2 by taking new term only. Taking new term only. Don't add up. Okay, you add up. Okay, the second term here you have 2 times. So it become coefficient is negative 1. So this is a general solution for exact differential equation, which is fxy equal to a. Okay, and the question is actually given the initial condition. Yeah, Eugene. Okay,
Doctor, sorry, I don't understand.
yeah,
The
which
GYH, the
okay.
GYHX thing.
Okay, gy, this is function of y. To get the gy, okay, you look the gy into the second equation, mean must be only the y term. The y term consists of y only, so which is y squared over 2. That's why if you start from equation 1, your fxy is actually negative cos 2x over 4, okay, minus x squared y squared over 2. Gy is actually here. That's why here. If you start from equation 2, then you have these two terms, hx function of x. You look at equation 1, only the x term here. This is x and y term, so it's not. Is it clear?
I see. Thank you, doctor.
Yeah. Or you confuse gy hx. Okay, if you confuse how to take gy and hx, okay, you may start from equation 1. You take this one, this one. Okay, this one just ignore it, and then you go to take the new term. This is a new term. That's why you have here. Okay, this term already taken, so don't take it anymore. We only take the new term. So you got 3 ways to obtain your fxy. It's either from equation 1. Equation 1 is actually we integrate respect to x. The constant is not the normal constant, but can be function of y. Because integration, this is partial integration. When you integrate respect to x, y also constant. That's why the constant can be y also. So gy, you go to equation 2, take only y term. This is only y. This is x and y cannot, and this one already taken, so don't take it anymore. fxy can be obtained by integrate the second term respect to y. When you integrate respect to y, x is constant. That's why the constant here is plus hx. It's not plus c. C is a numeric only. Hx can be x or can be normal constant. So if it start from equation 2, 1, 2, okay, you go to get the hx from equation 1, okay, x only, function of x only. So it's this one. Then we obtain this is general solution. But the question K1, the particular solution. Okay. Okay, obtain this one. Okay, given y bracket 0 equal to 2, exactly when x equal to 0, y equal to 2. X equal to 0, y equal to 2. So you plug in here. When x 0, so you have negative cos. Okay, 2 times 0 is 0, so divide by 4. Okay, x 0, then y 0. So second term 0, third term 0 equal to a. Cos 0 is 1, so you have negative 1 over 4 equal to a. Okay. Hold on. I think, sorry. Sorry, y is not 0. X 0, y is 2. So that's why I mistake there. Third term is not 0. Okay, only second term because x 0. 0 time, okay, anything you get 0. Third term, okay, there's a mistake there. Okay, third term, y is 2. So 2 squared, you have 2 squared divided by 2. So 4 divided by 2, which is 2. I put it properly. So cos 0 is 1. So you have negative 1 over 4 plus, this is, okay, 2 squared, 4 divided by 2 is 2 equal to a. So a is 7 over 4. Okay, so this is actually general solution. Given y bracket 0 equal to 2, mean when x equal to 0, y equal to 2. Plug in Beck's case, a equal to 7 over 4, we obtain particular solution. Means substitute a equal to 7 over 4 into general solution. So you have, okay, negative cos 2x over 4 minus x squared y squared over 2 plus y squared over 2 equal to 7 over 4. Okay, this is particular solution. Okay, you may okay, you want a nice form, you may multiply, okay, both hand side by 4. So you have negative let's say cos 2x, this multiplied by 4, so negative 2x squared y squared plus 2y squared equal to 7. Okay, you may have this form. Okay, this is a particular solution. Or, okay, you want to simplify further. Cos 2x is or you may leave this form, I think, like this. This is a particular solution. Okay, or this one. Okay, or in the, okay, I think in the that I gave to you, I further, okay, substitute the cos 2x. I erase this one. And just now, okay, you may leave here, this one. Okay, or you want to further, okay, substitute back cos 2x is 2 cos squared x minus 1. Simplify further, we'll get y squared, because here minus, this is, where is it? 2, okay, minus 2 cos squared. Okay. Okay, this is minus plus 1. Bring to the other side. This become 7 minus 1, 6. And then divide everything by 2. Okay, so it's either, yeah, just now. Okay, from here, you may have 2y squared 1 minus x squared minus 2 cos squared x equal to 6. And then divide by 2. Okay, just now you plug in the initial condition, obtain A is 7 over 4. So plug in A equal to 7 over 4. Okay, this one direct plug in A equal to 7 over 4. Okay, you may stop this one. Okay, you may stop this from this is particular solution. Okay, or this line is actually multiply everything by 4. Multiply everything by 4 and they combine together. So this is actually negative cos 2x. This is minus 2x squared y squared plus 2y squared equal to 7. Okay, combine these two terms here. Factor out 2y squared. When you have negative cos 2x, then we factor out positive 2y squared. So you have 1. This term is 1 minus x squared equal to 7. Okay, here. Or further simplify cos 2x at 2 cos squared x minus 1. And then lastly obtain here. So sometimes if you do the question and you see why you can obtain the last answer, maybe you need further simplification. Okay, so this is about the exact differential equation.